Okay, so we're live, and we're back for a second episode with Jim Anspach. I think this is our fifth,
Well, hang on. I call this a
a
continuation because with Jim,
continuation,
there is never a second episode. It is a
True. Part,
continuation
yeah,
of our initial discussion.
part two of countless parts to come. So, I
Anyways,
think this
yeah.
is our 15th recording, if I'm not mistaken, and I think that we left this at right about where we were just about to get into ASCE 38, which I think is where it's going to start to get interesting. Um, so maybe we should start with a general question of what brought SCE 38 about
ASC.
ASCE 38 about. Excuse my Israeli accent.
There was a convergence of events that all came together at the same time that really uh, pushed forward that development of ASC 38, or more importantly, involvement with the American Society of Civil Engineers with what we were doing at SODEEP. And that was several things. Number one, there was a continued push by some of the SUE providers that were beginning to pop up in the early 90s to service this new market, that wanted to have an association that would serve their interests in promoting this new concept that we had of going out with geophysics and identifying and depicting utilities on plans earlier than during construction. And one of the driving forces in turning to we're trying to figure out what to do with this push towards an association was to determine, well, what would the goals of such an association be? And unfortunately, those goals were not the same goals as what we had at SODEEP. The goals of the association, or those promoting the idea of an association, were to kind of rein SODEEP in and say, you've got to stop being as progressive as you are because we can't catch up and we're not getting the work. You're talking about this designating and this surveying and stamping utility plans, and we don't have the capability for that. We're hole diggers. We like to dig holes with our vacuum truck and expose utilities, and that's our niche, and you're going too fast for us to catch up. And we didn't want an association at SODEEP that would promote nothing other than excellence. And so we decided to do whatever we could to slow that effort down. Interestingly enough, here it is in 2022, and in 2020, we finally got to the stage where there was an association. So 20 years after the idea that we needed an association, the market was mature enough and the practice was advanced enough that it made sense to put an association together for that, the Subsurface Utility Engineering Association. But back then, I think that would have, in fact, halted the progress we were making, because we would have had to innovate by committee at that point, and that's never a good thing. So that was one factor, is how do we counter this association request by other providers as the subsurface utility engineering market was expanding throughout the country. The second was Paul Scott, the Federal Highway Administration utility engineer, and I were invited down to University of Alabama to present to the civil engineering class a lecture on utilities and how to deal with them in this new concept of subsurface utility engineering. So we gave a nice 90-minute lecture, and the incoming president of the American Society of Civil Engineers just happened to be the dean of the civil engineering department there at University of Alabama. So as we finished our day and we went to dinner, he said, I really liked what I heard. We have a problem within the civil engineering community in that engineers, even though they are stamping their plans and putting a disclaimer on it saying, I'm not responsible for utilities. Utilities are the responsibility of the contractor at time of construction. The courts were not always honoring that particular disclaimer, and they were starting to decide in some cases against the engineer because, in fact, there are methods to address the utilities early, and we were providing some of those methods. So he suggested that ASCE might be a great organization to help create a standard for engineers that would help protect those engineers using the concepts of the quality levels, although we didn't call them that then yet, but the idea that different methods of obtaining utility information and using those methods and differentiating them on a set of plans might be able to provide the engineer some protection. So that sounded good to me, and we discussed a little bit that, maybe ASCE could be our association, so to speak, that would allow the profession to continue to innovate and advance within the realm of engineering rather than within the realm of contracting, which is where some of those subsurface utility engineering providers wanted it to stay. So that was really the impetus to get ASCE 38 in development, and we put together a proposal for ASCE on that, and they accepted the proposal, and we put together a committee, and we were off and running.
How long did that take you, Jim? Because I know, for example, the ASCE, what was it, the ASCE 3819 or 20, 21, 22? How many years did it go from inception? Because it was actually released in 2002 because, of course, ASCE 3802. But when did you actually start working on that?
We were in Alabama in 1994, as I recollect, and we had the committee put together and formed by 1996, and we published in January of 2003, although we called it 2002 edition because that's when it went to publication. So even back then it was a 6-year effort going from zero to a finished product.
Now, when we started with the standard, or when it actually got published, what type of uptake or what type of what type of reception did it receive within the community?
Well, it was a muted reception. I mean, there were those of us in the know that were very excited about it, and Federal Highway Administrations was very excited about it and was promoting it heavily. But throughout the engineering community, just like anything else, it was a matter of an education process because we were fundamentally changing the way that civil engineers understood the practice of depicting utilities on plan sets would be. And it's an education process that continues today. It has never really stopped, and it never ramped up asymptotically the way I thought it would. It has been a slow slog in getting engineers to understand it. And one of the main reasons was trying to get anything new adopted into the academic curriculum, especially at that undergraduate engineering level, is very difficult because we just don't have the time to cram everything in 4 years of instruction that needs to be crammed in. And so there was never an orientation to the new students coming out in the world that this standard existed. Um, and therefore, the way students learned was from their mentors on the job. And those mentors grew up addressing utilities a different way. So it has been a long educational process to the engineering community um, that has taken a lot longer than I thought it would. I didn't realize the magnitude of the effort then, but I appreciate it now.
So, Jim, with your starting off and with getting the community to accept this, were there any real champions? I know that, for example, up in Canada, there were a few municipalities that really championed it and really pushed it forward. Were there any real champions which joined the Light Brigade to charge against the tanks of, proverbial tanks of stagnation?
Well, there were certainly champions amongst the providers, although not too many. Tampa Bay Engineering certainly joined with SODEEP, and between SODEEP and TBE and FHWA, I believe that was truly the triumvirate push to get the standard uh, uh, not necessarily adopted, although we tried to get it adopted, but certainly promoted and tried in within their system. APWA and FAA, Department of Energy, Department of Defense, all of those organizations paid good lip service to it. It sounds like, and it was a good idea, a great idea. And they said, yes, we need to endorse this standard going forward. But again, those organizations also are slow to change. And so it took a while to get beyond the initial endorsement stage and actual adoption.
Now, when I'm looking at the ASCE 38, it's a very small book comparative, if we're comparing to other standards or other best practices. And there was a lot of things over the years which have been found to be very loose in terms of interpretation. When you were putting it together, was that the intent that you let the industry decide how to interpret it, or was it we'll call it a compromise of actually getting it out?
Well, that's a good question, and I struggle with that answer. When we put it together, we thought that it contained enough language that it would get the job done, with the assumption, and it was an incorrect assumption on our part, but the assumption that everyone who read that would understand English, not take it out of context, would actually want to provide services with an eye towards excellence rather than mediocrity, or doing the least amount possible to say that we complied with this. And so there were a lot of phrases taken out of context. You have to read that standard in its entirety and understand how those particular clauses and requirements fit together. We thought we did a masterful job initially, and going back and reading it again, I think we did a very good job, but there were some areas that were left general because we thought that, again, the industry would interpret those in such a way as to strive for excellence rather than not. And that was a mistake in our understanding of how non-mandatory standards are looked at and perceived by the engineering community and their clients just as much.
So one of the biggest things which I've always found with the ASCE is the iterative process of ABCD or DCBA, and only after years of really being involved in it did I finally get the clue that, and especially with many discussions with you, that no, that it's not just going from DCBA, it's starting off with B and then filling in with the C and D where you could not do it, and then actually looking at critical path and deciding where the A goes. So really, it also took me a little while, even though I was entrenched in the industry, to remove myself from that iterative process of escalation or de-escalation in terms of quality level, and really start to focus on trying to do everything B and then filling it in. So
Yeah,
especially
so
with conversation with you, yeah.
yeah, so that was an interesting development. When we started the concept, it was let's use all the geophysical tools that seem to have promise in a particular situation and try to find utilities in spite of not having records or in spite of obstacles that were out there. And when we couldn't achieve a geophysical resolution, we would have to default to a secondary resolution or tertiary resolution, which would be if there were visible features that we could exactly position through accurate survey. We could call that quality level C, and if there were no physical features or an insufficient number, we could call that quality level D. However, when we were putting the standard together, the Federal Highway Administration was very cognizant of the fact that state DOTs, and that was their market, state DOTs, they were cognizant of the fact that state DOTs already had, for the most part, a process that would get them to the point just before geophysics. In other words, in the planning stage, they would typically contact utility owners and say, give us your records. And somebody would try to put that record information on the plan set. And then they would get a topo surveyor to go out and survey all of the topo features out there and put together the topo plan set. And then somebody might try to rectify the records to that topo. And that looked an awful lot like quality level C or D. But it wasn't quite exactly the same. So as we were developing the standard, what we thought was, well, this could really serve a dual purpose. We can get the buy-in of the state DOTs by not altering very much their existing process and introduce this as just another step in their existing process. And that was probably not necessarily a mistake, but something we didn't understand the effects that would create for some number of years. Because what happened was nobody ever wanted to go to the quality level B stage, which was where we wanted to start. They all said, well, let's just do D and C. That's good enough. And that complies with this standard. And while on the face of it, it did comply with the standard, it left a lot of room for the potential benefits of the process to be left off the table. So
Yeah,
that was an issue. And when we when we came up with the language in 3802 that said, in order to achieve quality level B, you must do quality level C and D, that was also not understood the way we thought it would be understood. And what we meant by that was, if you're going to do quality level B, then you have to do a visible site survey in that area, and you've got to do a records research also, and look and synthesize those three sources of information together before you could call it quality level B. It didn't mean that you had to do quality level D first and then C and then B. It meant that those three sources of information needed to be synthesized into the final product. And it took a long time for us to realize how it was being interpreted and how to get around that. And I think the latest edition of ASCE 3822 is much more clear in those regards.
Now, one thing I'm really not surprised at, but just in awe and wonder, just how far technology has come over the years. And my best example is when I started working in the field, when I started working in this field, I came from a military background, and I was going, okay, where's my GPS unit? And back then, there was no GPS. It was not in the civilian field. Back then you were still doing traditional terrestrial survey, with total station, and just the evolution of how all the different pieces of technology have come into play. Did the original ASCE account for the technological revolution or the digitization, or did we have any foresight into that?
I think we did. I think we were quite good at anticipating, because we had seen the change just in the short period of time that we were in existence at SODEEP. When we started, we had plane tables for survey. When we started, we only had several different types of geophysics. When we started, we didn't have CAD. We were hand drawing sets of plans. And so we saw that very quick evolution of technology. And remember, we were in fact integrating geophysics, survey, and engineering all at the same time. So we actually, I think, got a chance to see the wave of technology well in advance of many others, by seeing how all three of those professions were in fact advancing and integrating into the whole. And I look back on some of the early research projects with the National Academy of Science and the National Science Foundation in automated construction, and working with Caterpillar and John Deere and Red Whitaker at Carnegie Mellon University. And I remember seeing my first GPS unit on his tractor in his field, saying, look at this, I don't even have to drive this thing. It goes where I tell it. And that was 1991, and this was, wow, this is really interesting stuff. So I think we anticipated leaving the standard generic enough that we could integrate new technologies into that without any kind of a conflict with the existing language. And that is one of the reasons why the standard didn't get upgraded or redone for such a long period of time. Most standards get revisited every 5 years because of advances in technology causing conflicts with the existing language or calculations within those standards.
Now, one thing I did see from the ASCE 38, it also spun off a whole bunch of other sites, like the Sharps and the ACRP Census 34 for the FAA and airports, and all these different research projects which actually came out of it. Was that intentional, or was that a byproduct of a good standard or a good best practice?
Well, it wasn't intentional. It had no bearing on developing ASCE 38 in the first place. But after it was developed and in practice, Paul Scott and I recognized that there was a lot of research money out there for things like construction and automated construction and new survey tools, but there was very little focus specifically on utilities. Most of those were the manufacturers themselves, but there was nothing for the process of how we dealt for utilities. And Paul took that information to heart and really behind the scenes advocated along with myself and Nick Zambellis within the federal government, whether it was with legislators or administration officials or the various science organizations, that it was time to spend a little bit of money in utility research. And as the Strategic Highway Research Program was being spun up and funded, he was able to convince the powers that be that this was in fact a good place to put some research money. And we got quite a bit of money for utilities, probably for the first time ever. Now, a lot of that came out of the Department of Energy, who was the one agency putting a lot of money into utility research. And it was mostly for finding not so much utilities, but buried drums and tanks and the utilities in between those on Department of Energy sites. And how do you deal with that remotely because of the hazardous nature of that? So they were putting a lot of research money in and failing quite a bit at their attempts. So I think that they had a big say, and there were some key individuals within the Department of Energy there that helped push the federal government towards, and the Department of Transportation, into putting some of this research money into utilities in general to take some of the burden away from the Department of Energy.
Now, throughout the years, from what I've seen over the years of my involvement in the industry, I think from 2007 to around 2013, 2014 was that heyday of SUE where it was really getting great traction. I can say that across Canada, it was getting great traction. It was being added into procurement documents, and it really started on an upward slope. And then all of a sudden, I started seeing a lot of watering down of the I'll call it watering down of the actual deliverables, and saying, wait a minute, maybe this does not need to be an engineer. Maybe this is okay, just the few technicians going out and actually calling it quality level B and so on and so forth. What do you think brought about the watering down of the actual standard to what it was intended to be versus what was actually being produced?
Well, there were a couple factors. I think one factor was there was a market and it needed to be filled. And the existing subsurface utility engineering companies that were doing a high-end product couldn't necessarily fill all of that market. So there was that. I think there was also a realization by the survey industry that things were changing. All of a sudden, there was no longer although there was a need, there was this new technology that enabled survey accuracies and precisions to be achieved by the common ordinary person. And all of a sudden, the survey world was in this transition phase of, gee, does anybody really need our services anymore other than for deed research? and meets and bounds, and how do we get our topo survey back, so to speak. And so I believe there was this increasing push uh, for the survey uh, uh, industry to figure out how they were going to evolve in this new market with new technology. And they looked at this concept of, oh, utilities. Well, we used to just disclaim those and only indicate what we could see. Why don't we team up with somebody who will allow us with this new concept of a quality level to put this information on our plans and say, yeah, well, we can give it to you, but we can't give you any kind of accuracy. Whereas before they shied away from that for liability reasons, now there was a mechanism for them to somehow mitigate their liability by putting a quality level on it. So all of a sudden we brought the survey industry in, and I think just about the same time, the GIS industry uh, kind of split off from the survey industry, and they were looking for uh, something more exciting and rigorous for them to do. And so all of a sudden it became, well, no, how about a GIS professional also doing this work? But gee, we don't have any stamp anywhere in the country, so let's make it a non-stamped industry, and that's how the subsurface utility mapping or SUM industry kind of sprang up about that time frame, saying, well, we can do everything you can do, we just don't stamp it, therefore we can do it cheaper, and nobody seems to care. Everybody's looking, not everybody needs a Cadillac, right? Sometimes a Chevy is good enough, and that was how clients were looking at this.
That's really interesting. Is that also one of the common aspects of why UESI was formed to help advocate for the professional side? Because UESI is the newest institute within the within the ASCE. So really interesting how these
Yeah.
all come together.
Well, in I actually have an email going back to 1996 with Dr. Tom Isley and myself talking about, uh, hey, we need a new institute called the Utility Institute within ASCE, and ASCE was just starting to develop its institutes in the 1990s, and we recognized back then that uh, utilities are a big enough segment of civil engineering that perhaps its own institute would be an advantage. However, we didn't have enough traction back then to really make that happen, and so it took quite a long time for us to get traction within ASCE and for ASCE to evolve and put together new committees like the Committee for Technical Advancement, which looked at taking uh, aspects of civil engineering that were either very unique, like aerospace engineering or mathematical modeling, and those parts of civil engineering that spread out over all the institutes, like pipelines or survey and geomatics, and figure out how can we make ASCE more efficient and rearrange the organization of ASCE to be better for the industry. And that's really, I think, in 2010, 11, 12, under the direction of Jim Rosberg at that time and others, Tom Smith, that we were able to get the impetus together through the Committee for Technical Advancement to put the idea of a utility engineering and surveying institute together.
And I believe the first publication came out with was actually the UESI or the SUE for municipalities, I believe. Was that the first one that they actually published?
Yeah,
Or?
that that's probably um, could be construed as an accurate statement, although because we incorporated the pipeline division and we had an annual pipeline conference, and the proceedings of that pipeline conference were published every year, I would say that probably our first publication was truly the proceedings of the pipeline conference in 2015 or 16. But the first standalone document that was conceived outside of the existing pipeline division was that SUE for municipalities.
And what brought that about? Was that to give more to give some clarity? Like, I know that you were telling me that in our many discussions about the APWA and all these different organizations, which were trying to get clarification of how to use the SUE process within procurement, and what really brought that about for you and all the other people who initiated that guide?
Yeah, so as I mentioned when we started out, one of the early endorsers of the concept of subsurface utility engineering was the American Public Works Association, and we had several key documents or events that took place. One of them was a Kansas City public broadcasting system series of events where there were four of us on the local TV station that was then offered to the rest of the PBS world about utilities. And that's where it was introduced. And from that, in 1994, APWA put together a SUE for municipalities booklet. This was before there was the concept of ASCE 38. So it was, early days for that. And back in 2010 or so, maybe it was even earlier than that, 2008, I don't remember exactly, but Bill Kiger from Pennsylvania One Call, Pennsylvania 811, who was on the UPRO committee for APWA, which is the Utility and Public Right-of-Way Committee, asked Paul Scott and I if we could update that publication. And of course we said, sure, we'd love to update that. And we started looking at that and looking at taking the existing document and tweaking it to include all that had happened since 1994. And after about 4 years of trying to do that, we gave up. And quite frankly, we just threw the whole thing away, except for some of the examples of municipal projects that had used the early concepts of let's use some geophysics and exposure to mitigate municipal engineering projects. And we really came up with a document that in no way looked like the original. And we talked to the UPRO committee, and they agreed that perhaps UESI or ASCE and APWA could figure out a way to publish this jointly as a joint publication. And we put those two publication departments together, and nothing ever came of it. There was just silence on both sides of that, and we decided to go ahead as a UESI document with an UPRO endorsement for that document. And so we put that together, trying to take into account what are we trying to do with this document. We're trying to incorporate the concept of ASCE 38 and common practice and educate municipalities about this engineering process that would be beneficial on their projects. But one of the things that had always been lacking in our industry was, what are the pre-qualifications of providers, and what is a scope of work that is compatible with ASCE 38? What does that look like? And so we wanted to make a guide that would have some either an appendix or a chapter. We ended up with chapters for it that would spell out that if you're going to be using ASCE 38, here in fact are things you should look at from a pre-qualification standpoint, and here are things that you should look at from a scope of work side of things that would be integrated into ASCE 38 concepts. And so that's really how that document came about. So our idea was at the end of this publication, we would have, and remember, we were simultaneously updating ASCE 38 and creating a new utility as constructed standard or as built standard, now ASCE 75. So we wanted that triumvirate of documents, two standards, one on existing utilities, one on new utilities, and then an idea of how to integrate them into a scope of work and make sure you got a consultant who knew how to use those into these three documents that could be purchased and used by a public agency, not just a municipality, but a public agency to improve their overall utility program.